single piece flow or batch heat treatment. Machining of the parts has been done for more than several years in a single piece flow manner. Heat treatment as a batch heat treatment. Is it possible to transfer single piece flow treatment to a furnace to make a single piece flow heat treatment? Let's find out. Today I'm gonna take you to a very interesting company from aerospace sector here in southern Germany, in lovely town of Friedrichshafen. My name is Grzegorz Głuchowski, and please come with me to ATT. We are in front of Aerospace Transmission Technologies, and now we're going inside to see what's happening there. Come on. I'm here today with Mr. Fink from company Aerospace Transmission Technologies. Thank you very much for hosting us.
You're welcome. Hello.
It will be our pleasure today to learn more about the furnace that ATT has got installed here, about the process and about all the advantages that they got by implementing vacuum technology in the production process. So Mr. Fink, if I can ask you to describe us briefly the furnace and the process that you perform on our furnace.
Furnace is being ordered as an austenitizing furnace in front of a hardening press, and the furnace is part of a fully automated hardening cell, and it's a vacuum furnace. Our vision was we will have the best technology for part quality, and yes, we will have the possibility to produce parts in really a perfect surface, if possible without blasting after heat treatment. And that means we need, in our opinion, we need a vacuum furnace in front of a press. My knowledge was that that's the first time someone tried to buy such a furnace and design such a furnace, and I was really happy for having a partner and finding a partner in SICO to realize this vision. In the beginning of the project, we had some discussions for the vision, and let me say, it was a hard work and was not really normal that SICO say, yes, we will realize. It's a risk also for SICO and our company. So the furnace now is installed and works. We are in the qualification mode for our future product, and the austenitizing furnace has some parts. We have, in reality, we say it's one furnace. Our name is UCM furnace. But in reality, we have two furnaces with 4 heating zones. And from the pressure side, we have 3 parts in this furnace. We have a loading unloading chamber for the pressure balance to load a main chamber with always vacuum in and heated. So, and the idea behind was that we open the door like classical air furnace, and the part comes out really short time, and we quench the part in a normal time in the press.
So we can say you open the vacuum furnace with hot part inside.
Yeah, without temperature, less for pressure balance and other internal work for in the furnace. So that means for the part, if the cold air from the environment comes to the part surface, it's classical like a normal gas furnace. And that was the vision, and I think that was important. important for a good surface, to reduce maximum the intergranular oxidation, and also to protect the surface maximum for decarburization and everything. So that's the story behind the furnace. Now I can tell you that the furnace works. In a fully automated cell, it's not allowed and it's not really planned to do something by hand. Everything is automated. That means a lot of interface work for the participants, and the furnace is one of the main things in the hardening cell. That means, for the program people, a lot of work.
Yes, I think
during the project. That was the most critical thing, to close the interface to the others and bring the part in short time, with the right speed, with the right position in the press.
Yes, I think it is very important here to underline the fact that it is the hardening cell, as you name it. It is not only the furnace, but also the press, the robotic arm, and all the other equipment that needed to communicate with each other. And I can imagine this required a lot of effort from every party involved, with ATT coordinating everything. Yeah. So if you say that this works right now fine, it is very good to hear. And I also think what you said, why you choose vacuum, and it is also very good to hear that you confirm that vacuum technology is something that gives you advantage, that makes your parts, makes the surface of your parts better in comparison to traditional atmosphere technologies.
Yes, that's right. I think that was always my intention. You have two problems. Our part is carburized, sometimes double carburized in front of the austenitizing, and I think austenitizing after carburizing is always a bit of problem. You have to protect a carburized surface. Yes. You have to know what C content you need in furnace to protect perfectly neutral the surface. In a vacuum, in general, it's easy. Yes. You have vacuum, it's neutral. And if the vacuum works well, then you not have to respect the austenitizing. In my experience, otherwise you have to optimize the carburizing cycle. If you have a decarburization a bit in the austenitizing furnace, you have to over-carburize by carburizing, or you have to reduce if you have a carbon level in your austenitizing furnace. In reality, it's not always easy to calculate this right. Sometimes in the
it needs a lot of experience from the technologists.
And vacuum furnace by austenitizing makes it easier and brings you more stable results.
So the parts that you manufacture, they go into aerospace industry, where the safety is key point. Can we say that due to vacuum treatment, the safety of this part is increased?
Yeah, for me, yes.
About the part itself, can you say something more? Where is it installed? What's the purpose of it, more or less?
Yeah, we are founded to work for a new generation of aerospace turbine generations, and we are working especially for gearbox. And the part of this gearbox is a Planet gearbox design, and we have gears inside, and these gears are really critical. We interested to do the job for big airplanes. That means the gearbox is really a bigger one, and that means that our part weight for a gear, for one gear, is maximum 70 kilograms, and the gearbox is not small. It's a dimension around about 1 meter and more, and the maximum horsepowers at the moment are 87,000.
That is
means
amazing.
it's I think it's world record now
Yes.
for a gearbox, and that means it's really a critical part.
Yes.
And it's really not easy to do something like let us try and error. It's not aerospace. It's not allowed for our product. Absolutely not allowed.
Yes. There's 87,000 of horsepower. That is hard to imagine. I suppose 500 or 600 horsepower in a car, that's already a lot, but 87,000, as you said, so world record. And it's hard to imagine how big is the force that this gearbox needs to transfer so that it operates in an aeroplane 10,000 meters above the ground in safe conditions. So
and also we have to be sure that our part is not the reason for an accident.
Yes.
And that's really our motivation to invest in visions and try to make the processes safe and more controllable. That's our motivation, and that was the reason why we do the risk and why we invest in such new technologies a bit.
We are more than happy that we could be a part of this whole project and help you in increasing the safety and the quality of the gearboxes, of the parts used in aerospace technologies. As you said, it was a combined project. Many parties were involved. It was a risk for ATT and also for our company. New project, new visionary project, something that we have been also developing for a couple of years already, the UCM concept. You were not afraid to go into it, and it paid off, I suppose. But if I may ask, what was the biggest challenge as you look at this project at those last 3 years? What was the biggest challenge for you to overcome here?
I think one of the biggest challenges was that we have an internal transport. That means it's a single piece flow furnace in general. That means you can load one piece to the other, and the furnace can work in the single piece mode. But then we find out that it's also important for us to have a bit like a batch size treatment. That means then you have a different style of treatment, and the furnace has to work in different modes. That was a challenge to realize by ourselves, and then you have to realize it in the hardware. Also, we find out that we have different parts of furnace, and the parts of furnace are separated internal. We have internal pressure doors, we have internal thermal doors, and these doors need space. And it's not like a one chamber furnace in a dimension of 6 or 8 meters. We have doors between, and these doors is metal, is cold metal, and that was also a challenge to modify the furnace after installation to reduce the heat loss between the chambers, the internal chambers. You see it, you don't see it outside. It's all thing is inside, and was a big challenge to modify everything that we have now a good condition to transport inside in a furnace glass, in the needed furnace glass.
Okay. Yeah, it is very interesting to hear all of this experience and all the points that I would say we have overcome together and solved together as two companies, or even more involved companies. And as you said, new project, prototype project for all of us. Are there any things that you could have done differently right now, or maybe if you would to put up such an installation once more, is there anything that you could change, improve?
It's neutral that and it's normal that you have then a new furnace. In my experience, if you will have two furnaces and you have 2 years between, and you order the standard furnace, it's a different.
Yes.
It's not the same.
Yes,
so that
evolves.
means always it's you have to do something different. But let me say, it's nothing to say that doesn't works. Absolutely not. That's not working. I find no part. There is no working.
Okay.
But you can optimize everything.
Of course.
That's always in the reality. I think could be a good idea to reduce heating zones that save costs.
Of course.
Number of sensors and everything for the standard costs of a furnace. But in general, I think no, there is nothing for absolutely needs to change at the moment. But I think the system is really new. We have not a big number of parts. They are treated. And now we need the experience of serial productions. And after 1 year, you can ask me again, and then I can answer in the right way.
I will do for sure. But I really appreciate your openness on every stage of this project. And I think it is due to the openness on every side of the parties involved that we all were able to close this project with a success, and that the furnace will be helping you in improving aerospace parts, like for all those aircrafts flying above us, as we are near the airport in Friedrichshafen. So to finish up, I would like to ask you the last question. How do you see the future for aerospace industry, for aerospace critical parts like the gearbox you produce, providing that now we can implement vacuum technology and provide highest possible currently purity to the parts, how it can influence the whole aerospace business?
As I said before, I think, and in my opinion, the quality of the parts, you have a better control of complicated treated parts, and I think it's a good way to have normal quality for serial production. In my experience, sometimes you have different results but same treatment, and this is one austenitizing with air inside or gas inside could be 1 point, one point to have different qualities and different results, and that reduce one of these parameters, and that, in my opinion, that brings better chance of good quality for the future. That's my answer.
So vacuum furnace means repeatable process results with best possible quality.
For surfaces, yes. And by carburized part, the surface is always point of interest.
Yes. Exactly.
And also to reduce the rework or work after heat treatment, for example blasting, it's different to have an oxide layer of some microns or only 1 micron. It's easier to remove. That saves money and also brings quality, in my opinion.
Thank you very much, Mr. Fink, for your openness, for all the comments and this insight to ATT, to what you do. It was a pleasure for me, for us to be here together with you, to learn more about the final outcome of the project. What I can say less is to wish all of us a better future, no COVID, and that would mean a lot more business opportunities for all of us, and I think it's right now.
Thank you very much. It was also a pleasure for me.
Thank you very much.
Thank you.
That's it for today. Thank you for being with me here at ATT. I hope you enjoyed the interview and valuable information that you've got from Mr. Fink. Bye.